We will try to solve some problems based on self and mutual inductance in this session. First, take down the first one. A magnetic field of 5 Tesla acts normal to a coil of 100 turns having 100 centimeter square area. Centimeter square area. This is, you can write square, 100 centimeter square area. Find EMF induced. If the coil is removed from magnetic field in 0.1 second. Let us try to understand the problem. A magnetic field of 5 Tesla acts normal to a coil of 100 turns having 100 centimeter square area. Find EMF induced if the coil is removed from magnetic field in 0.1 second. Now here there is an EMF induced because the coil is quickly moved out of this magnetic field. Now the induced EMF is given by, how do we calculate? Induced EMF, E is d phi by dt, and if you use n into d phi by dt, and if you use the equation, like if you use the equation with sign, it will become minus n into d phi by dt. Now here dt is given. The change in flux happens within a time period of 0.1 second. Now number of turns is also given, that is 100, but d phi is not given. That we have to calculate. Now d phi is nothing but change in flux, so it is always calculated as phi 2 minus phi 1. Now what are phi 2 and phi 1? Now the coil is removed from magnetic field. The coil is removed means at the end the flux will be 0. Why? Because the coil is already removed from the magnetic field, so flux linking the coil will be 0. Therefore phi 2 is 0. Now what is phi 1? So phi 1 is B into A, N into B into A, but N I have already taken here, so it is B into A. Therefore induced EMF E is minus N into d by dt, or d phi by dt will substitute directly. Phi 2 is 0 minus BA divided by 0.1. So that will become equal to NBA divided by 0.1. What is 0.1? That is dt. How did I get this? This I have substituted in the equation. E is n into phi 2 minus phi 1 divided by dt. Phi 2 is 0, phi 1 is b into a divided by 0.1. Now substitute all the given quantities. N is 100 turns. What is B? It is 5 Tesla. What is A? 100 centimeter square. Convert it into meter. So it is 100 into 10 to the power minus 4 divided by 0.1. Now when you do the calculation, this 100 into 100 will become 10 to the power 4. That will get cancelled with this 10 to the power minus 4. So this will be equal to 5 by 0.1, which is nothing but 50 volts. Induced EMF E is 50 volt. Now we'll do another one. Now take down this. What is the second problem? What is the self-inductance of a coil in which magnetic flux of 40 milliweber is produced when 2 ampere current flows through it. What is the self-inductance of a coil in which magnetic flux of 40 milliweber is produced when 2 ampere current flows through it? Now first write what are the given quantities. Here given flux phi is 40 milliweber. Current I is 2 ampere. Now calculate what is self-inductance L. We have the equation. Self-inductance is given by phi by I. What is phi? Phi is flux, that is 40 milliweber. Milli is 10 to the power minus 3 divided by 2. So it is 20 into 10 to the power minus 3 Henry. Unit of L is Henry, or it is 20 millihenry. Self-inductance is 20 millihenry. Self-inductance L is 20 millihenry. Now we'll do one more, that is based on mutual inductance. When a current of 3 ampere flows through primary coil, a magnetic flux of 30 milliweber links with the secondary coil. Links with the secondary coil. What is the mutual inductance between the pair of coils? Now here actually there are two coils, because the mutual inductance comes into picture only when we have two or more coils. Let me draw two coils. Now the current in one coil, let us say 3 ampere, the primary coil. I'll mark it as I1. The current 3 ampere flows through primary coil, and magnetic flux of 30 milliweber links with the secondary coil. The flux linking the secondary coil is 30 milliweber. So let us write it as phi 2. Now what is the mutual inductance between the pair of coils? Now we have the equation for mutual inductance as mutual inductance M is phi 2 by I1. M is phi 2, that is 30 milliweber, divided by I, 3 amperes. This will be 10 into 10 to the power minus 3 Henry, or M is 10 millihenry. The mutual inductance between the pair of coil. M is 10 millihenry. This is how we calculate the mutual inductance between the pair of coils. In the next session, we will learn about the principle of AC generator.